join stereo matching and semantic segmentation with CNN. And first is about the introduction. This stereo matching and semantic segmentation are two popular topics nowadays. And here we briefly show you the basic idea of these two things. The first is about stereo matching. We use two images, and the object will have the pixel shift on different images, left one and the right one. We can make use of the pixel shift to compute the depth of this point. And for segmentation, we have the input is an RGB image, and the output is a matrix of different labels. One, you see the same class of object will have the same label, and this we try to join these two different tasks together. So before we start our experiment, we first examine our idea on a small synthetic human figure dataset to verify our idea. And you see the left one is only the output of segmentation, and the right one is the output of network with segmentation and the disparity both. And you can find that the human contour is much smoother than the left one. And in this example, we can have a simple proof of our idea. And
Then
about the data.
we move to the dataset called Cityscapes. The Cityscapes is a complex dataset have the 19 classes, which is an urban, which has an urban sense and understanding, and its origin size is very large, and we think this dataset can improve our idea. And about the model, our model is based on the FlowNet, and the input of the encoder part is the left image and the right image. Then we do the convolution directly, and then we do the correlation to put the left image information and the right information together to do the rest network part. And after the encoder, we divide the text into two parts. One is for segmentation, and the other is about the disparity. And all the features the left and the right features can be used together to do the deep neural to get the features.
And this is the basic network structure of our experiment. And also we try different algorithms to improve the result of our network. In this algorithm, we first implement two multitask training algorithm. One is alpha layer and join, and another is join loss layer. And about alpha layer,
The alpha layer is a linear combination of the two features. Just like the right side pictures, we can input the left and the right part of the features and have a linear combination together to get the output. About the parameter alpha can be automatically calculated by the backpropagation and upload by the network itself.
and second is about the join loss layer. Because you can see our network, we have two losses. One is segmentation loss, one is disparity loss. Some researchers think that we can not only do them separately, we can combine the two losses together. So they assume the output of each point is it follows the Gaussian distribution, and they use search formula to get the joint loss, and they want to minimize the loss through this function. And also the mu here is for different tasks, and these mu's can also automatically updated through backward propagation. And also, they prove that this may work on their dataset, and on their network on Cityscapes, and we will later do it on our network. And second is about the about the modification of the dataset, because 3,000 image is quite small compared to other datasets. So we try to we try to do data augmentation in this part. And first is about the balancing the dataset, and second is about cropping the original image. For balancing the dataset, we find, after analyzing the dataset, we find that the percentage of different class are quite different. In extreme case, it will only have 4% of all the image. So we want to balance the percentage, and we try to double or triple the image with lower percentage in this experiment, and the result will show later. And about the crop.
The cropping image is because limited by the GPU memory, and we don't want to recite the image in. We want to get the result from the original image, so we random crop the original image into some pieces. So each image can get about 8 to 16 image for each one, and the result will be shown later.
And the last three, batch normalization, dilated convolution, and deconvolution and interpolation, are some conventional training tricks for segmentation networks. But for the original FlowNet, they don't have search parts, and then we will test it in our experiment. And finally, we got here we show the results. We divided our work into two parts. In the first part, I use the smaller image to get a higher training speed and efficiency, so we can test more. We can test different settings in this part, and you can see I tried different combinations of the previous algorithm we mentioned, and we find that the joint loss layer doesn't work well because the model of our network is far different compared with the model provided by that paper. And also we find that after double the lower percentage classes, we can get significant improvement on those classes, and maybe some of them will impact from will suffer from overfitting. And later, we test those settings on the origin resolution through cropping image.
And the result of the origin cropping, the comparison is between the segmentation with disparity and the model with only the segmentation. We can see that each class has a great improvement especially on the low score part, and even the high score of the road, we can also see the improvement. Which we use the result to want to prove that our idea also works on this model with the cityscapes.
And now we have already proved that our idea works for low marks on the benchmarks. Our final result is about 65, which is quite low on the benchmark. So so our next step is to do experiment on higher score models, such as
Just like as the PSPNet. PSPNet is a state-of-art model about 80 accuracy. So we want to put our disparate information onto this model and to do more experiment to see what improvement on this.
So in conclusion, we done search experiment on start from the FlowNet and gain around 7 to 8 percentage improvement, and our later experiment will do on the state-of-the-art network, and that's the